Hi, Year 11. So here we go. I'm going to be doing solutions to exam paper 2016, exam 1, and then I'm going to do multiple choice with the CAS. And I'm going to then do exam 2 as well. A few things to note as I'm doing all this, I think some of the topics that's worthwhile sort of revising that hasn't been on these 2015, 2016, 2017 specifically would be counting methods, your combinations, your probability, just a bit of those would be good for you. I'll try to find, I'm pretty sure there's an integration question that you would probably should know, just because I haven't gone through that type of questioning. So hopefully this video will be useful. Other than that, I think for the most part, your calculator skills should be all right now if you've been watching the 2017 paper. Okay, so let's start anyway. Here we go. Question 1, 5 marks. We've got a sine graph. And again, hopefully we can read the equation here. We've got a domain. It tells me it's from negative pi to pi. I've got the amplitude, which tells me it is 2, and this plus 1 tells me up 1. Now for those, and clearly there's no negative, so there's no reflections anywhere. So I know the sine graph should normally look like this. That's your normal sine graph, 0 to 2 pi. Okay. The things you have to check is the period. Is the period still 2 pi? And in our case, yes it is, because n, which is the number in front of x, is still 1. So it's 2 pi on n, which is 2 pi on 1, and that gives you 2 pi. Okay, so that just tells me that starting at 0, going through the cycle, I land back at 0 after a distance of 2 pi. Okay, so that's what I know. But remember, I had an amplitude of 2, so if I drew it, this is amplitude of 2, negative 2, and it finishes at 0 to 2 pi. And so that means the middle here has to be then pi. But you have to also keep in mind that there was an up 1. There was a shift of 1 up. So if you would do this, then from the minimum, which is currently at negative 2, it will shift up by negative 1. So it's at now negative 1. And then from 2, which is the maximum point, it should shift up to 3. Okay, so my graph and the center here, which is at 0, should move up to 1. So that means everything moves up by 1 by 1. So technically this is the new graph that you should be getting. If you can see how I'm sketching that. So I'm just going to rub off the blue and any other ones that might be confusing. Okay, there you go. So that still maintains that the center is at 1, but the amplitude from 1 to 3 is still 2, and from 1 to negative 1 is still 2. So amplitude is still 2, the width is still 2 pi, and this is still pi, so the period still works, and I've shifted the center line up by 1. So essentially this is what it should look like, right? But keep in mind there was a domain from negative pi to pi, so that means I would have to stop here and I have to go backwards up until negative pi. So if I were to draw it all in one go, this is how I would do it. Now that I've got a visual idea of what I need to do, this is how I would have done it. I would have drawn that it is a normal sine graph. So here we go. It started at 1, goes up to a maximum of 3, comes back down to the center, and that was at pi. Remember that? And if you continue it on, then that becomes 2 pi. True? But we don't want that. The domain was only up to pi. So I'm going to stop there. And now I'm going to say at pi, I've got height of 1. At obviously pi on 2, which is the quarter cycle, the height is 3. And I'm then going to draw the second part. So if I follow the pattern, it should then come back up and finish at negative pi. So here we go. This is my part of my graph. But remember, the minimum that it reaches, it has to be an amplitude of 2. So this has to be negative 1. Okay, so here we go. We've got our points. At negative pi, it is 1. At pi it is 1, and clearly at this point here at 0 it is 1. Okay, now it says label any axial intercepts. So I haven't labeled my x-axis intercepts and endpoints with their coordinates. Now I've labeled the coordinates of the endpoints, and the only thing I'm missing now are the x-axis intercepts. So how do you find x-axis intercepts? These are the points I'm looking for. You can only find them when y coordinate is equal to 0. So let's go back to our equation and we say, all right, well, y equals to 2 times sine of x plus 1. And we know that y equals 0 for the x-intercept. So 2 sine of x plus 1 minus 1 on both sides. Divide 2 on both sides. And now my goal is to solve for x, which then x would equal to sine inverse of -half. This is where you're going to use your unit circle. So again, if you've forgotten it, exam 2017, I did an example of this as well. Similar ideas. Sine is your y values. Where is sine negative? Because it's -half. Sine is negative down here. So those are the two quadrants. And what would the angle have to be? Sine of what will give you half? I go through the exact values. It is pi on 6. So now from here to here is also pi on 6. So now let's work out from 0 to 2 pi. If I'm starting from 0, I'm going around up to here is pi. But then with an extra pi on 6, I'll get my first solution. So from pi plus an extra pi on 6. And then I go all the way around to 2 pi. But remember, I hit my next solution just short of 2 pi by pi on 6. So I write 2 pi minus pi on 6. That gives me the first two solutions, okay? But remember the domain that we had was that x was between -pi to pi. So I'm just going to make sure that I fit within that domain. Okay, so let's get my answers here. I got, what's that, 6 plus 1, so 7 pi on 6. And I've got 11 pi on 6. These are my two answers. And clearly in my two answers at the moment, it's above pi. Okay, 7 pi and 6 is above 1 pi, and 11 pi and 6 is above 1 pi as well. Because in order to have 1 pi, it had to be 6 on 6. Now I've got 7 on 6, so obviously it's more than 1. Yeah? And remember the technique I taught you guys, that once you find the first two solutions, all you have to do is add and subtract the period until you meet the endpoints or the domain. So what's my period? We already worked out the period was 2 pi up here. So that means I'm going to be adding and minusing 2 pi until I get all my solutions. Okay, so if I write it out, now remember 2 pi, just in terms of fractions, because it's all out of 6 at the moment, 2 pi is the same thing as writing 2 pi, 12 pi out of 6. True? Okay, because 12 divided by 6 is 2. Yeah? Now, that means if I'm adding and subtracting, I'm technically adding on 12 or subtracting 12. So 7 plus 12 gives me, now I'm going to write here 7 pi and 6 and 11 pi and 6. Now if I added, I'll be going that direction. True? So 7 plus 12 will give me 19 pi and 6, which doesn't help because that's way above pi. And if I added 11 pi by 12, that gives me now 23 pi and 6, which again doesn't help. It's way above the domain. So what I should be doing instead is I should be subtracting. I should be subtracting by 12. So 7 minus 12 gives me -5 pi on 6. And then 11 take away 12 is -pi on 6. Now these two fit in the domain. See, -5 on 6 is not even equal to 1 yet, because 5 on 6 is not equal to 1, and 1 on 6 is also not equal to 1, so it makes sense that these two are my solutions and these don't fit. Okay, and it makes sense in the graph, I only had 2 points of intersection, so this had to be -5 pi on 6 when y is 0, and this other coordinate should be -pi on 6 when y is 0. Okay, there you go. Got my first 5 marks. I've sketched the 3, and then I've solved the 2 for the solutions, and that's my answer there. Okay, so label with the axial intercepts and endpoints with its coordinates. It says coordinates, so make sure to label the coordinates. All right, next question. Solve the equation. Wait, is that the same? No, that's a different question. All right, cool. So same drill again. We're going to do the exact same thing that we just did. We're going to divide both sides by root 2. So now you got cos of 2x is equal to negative 1 on root 2. And you're going to find that 2x is equal to cos inverse of negative 1 on root 2. And you go back to your unit circle again. Okay, and you say, well, when is cos negative? Cos is only negative in these two quadrants. And what would the angle have to be to get 1 on root 2? Well, going through your exact values, it would have to be pi on 4. Okay, so these are the only two regions where I get pi on 4. And remember, the domain currently here is from 0 to pi. So answering the question, if I started at 0 and I go all the way here, I get to pi. But I hit my first solution, just short of pi. So writing out my solutions here, 2x is equal to pi subtract pi and 4. And the other one is an extra pi and 4. So pi plus pi and 4. Okay, get your first two answers before you finish at 2 pi. So here's my first two solutions, just like how I did up here. I got my first two solutions here. Yeah, and then I added on and subtracted the period. That's exactly what I'm going to do here. I'm going to write 2x is equal to 3 pi and 4. And this is 5 pi and 4. Now, if I divide everything by 2, so x is equal to now 3 pi on 8 and 5 pi on 8. Yeah, because you're dividing it by 2. All right, now I've got my first two solutions, but remember I told you to make sure that all your solutions fit within the domain. Now these two fit in the domain, so that's good, but you got to check by adding the period and subtracting the period. Now what's the period of this function here? Clearly you've got an n value of 2, so it's 2 pi on 2, which works out to be pi. So technically I'm going to be adding and subtracting pi on each end to see which solutions fit. So here we go. We've got x is equal to, I'm going to write it out. I had 3 pi and 8 here, and I had 5 pi and 8 here. Let's add the solution. So if I added pi, remember, this is a denominator of 8. So to have 1 pi, it would be 8 out of 8. So technically, I'm adding 8. Right? So 5 plus 8 will give me 13 pi on 8. 3 plus 8 will give me 11 pi on 8, and both of which is out of the domain. What's the domain? 0 to pi. So these two fit, but these two are out of the domain. Now we check in the reverse. What if I subtract both of them? Okay, so if I subtract both of them, 3 take away 8 will give it now negative 5 pi on 8, and then 5 take away 8 will make it, what's that, negative 3 pi on 8. And again, same thing. These two don't fit in the domain, so it looks like my answer can only be 3 pi on 8 and 5 pi on 8 as my only two solutions. Okay? Yeah, so that's how I taught it when we were doing circular functions. Keep adding and subtracting your period until you get out of the domain. Obviously, initially when I first taught you, I made sure that you changed your domain so that you don't have to trial and error like we're doing now. But this is the easiest way to sort of understand it. So especially if you didn't pick it up beforehand, this is your method. This is how you do it. Okay. All right. Let's go to the next one now. Exponential. This is a typical year 12 question, like on what to do. When you see these squares, you should always be thinking, especially for exponential, it's usually a quadratic problem. And this is the trick. See, another way of writing this 2 to the power of 2x, another way of writing it is 2 to the power of x squared. Because with index laws, you can multiply the powers. X times 2 is the same thing as saying power of 2x. So the reason why I'm writing it like this is because now you have minus 2 times, again, 2 to the power of x is equal to 8. Now, what would be convenient is if I replace this and I said, let a equal 2 to the power of x. See, if I do that, then technically I now have a squared minus 2 times a equals 8. And that is so much easier. That's a quadratic problem, minus 8 on both sides. and you get this kind of problem here. Okay, you got a squared minus 2a minus 8. See if you can factorize it. So if we try to factorize it, we will now get, what's this? Maybe negative 4 plus 2. Does that work? Negative 4. Yes, it does work. And so therefore a is equal to negative 2 or a is equal to 4. But you're not done yet because a was a made up variable. If you write it out again, a was 2 to the power of x is equal to negative 2 or 2 to the power of x is equal to 4. Now we know from exponentials 2 to the power of anything will never give you a negative answer. Yeah, like 2 to the power of 2 is 4, 2 to the power of 3 is 8. But then if you try negatives, like 2 to the power of negative 1 is 1 over 2. 2 to the power of negative 2 is 1 out of 4. Yeah, so you can keep getting smaller and smaller, but you never get a negative. That's why if you draw the exponential graph, it's pretty obvious. You never get a negative y value. You get a very small, that's why we get an asymptote. So technically, this answer here is undefined. It's impossible to have any x values. 2 to the power of anything will never give you a negative 2, so that's undefined. But whereas on this side, 2 to the power of x is equal to, now 4 is the same thing as writing 2 squared, and we can say that, well, x then has to equal to 2. Okay, and that's solving for x, so x equals to 2. Next one, logarithmic, very similar again, using your log rules. We've got adding means that you can times it, but remember I said in class that they always do this in your exams, especially for next year. When they have a 2 at the front, always remember rule number 3, you can bring it up. So now if I rewrite it, I've got log 2 of 3x plus log 2 of x squared minus log 2 of 6 equals negative 1. Now using my log rules, when I'm adding the two logs and the bases are the same, so log base 2, log base 2, right? I can combine it by multiplying the insides. That's one of the rules, log rule number 1. So it's log 2 of 3x multiplied to x squared becomes x cubed minus log 2 of 6. And again, rule number 2 of logarithmic rules, we can say that if you subtract it and the bases are the same, so log base 2, then you divide them. So now it would be log base 2 of 3x cubed divided by 6 is equal to negative 1. We can simplify the 3 and the 6, and that cancels out to be 1 and 2. So now you've actually got log base 2 of x cubed on 2 equals negative 1. And if you remember how I taught you to remove log base 2, the inverse of log is exponential. So if I did 2 to the power of, because 2 is the base, 2 to the power of the left-hand side and 2 to the power of the right-hand side, I'm keeping the equation balanced. But the nice thing is base 2 exponential and log base 2 are inverses, so they cancel out. And I'll end up with x cubed on 2 is equal to 2 to the power of negative 1. Which is the same thing as writing 1 on 2. And this one is x cubed on 2. I know we don't like fractions, so like I always say, how do you get rid of the denominator? It's currently divided by 2, so we would multiply by 2 on both sides, and the 2 divided by 2 cancels out, and 2 divided by 2 cancels out, and you end up with x cubed equals 1. X will then equal to cube root of the 3 on both sides, and cube rooting cancels out, and the cube root of 1 is 1. Okay, so x equals 1. Next one, integration. This is an indefinite integral. So as you can see, find the indefinite integral. Remember the rule. I'm going to write out the rule. It's in your formula sheet that you will be given with it as well, but just in case you forgot, ax to the power of n. So if it's a power function, which clearly is, it's x to the power of 4, and this is x to the power of 1, and this has no x's. Is equal to a multiplied to x to the power of n plus 1 over n plus 1 plus c. Don't forget the plus c. Okay, that's the rule. Now if I use the rule here, then it will be 3x to the power of 4 plus 1, which is 5, over 4 plus 1, which is 5, plus 2 times x to the power of 1 plus 1, which is 2, over 2. And then minus, now a lot of students will get this one wrong because there's no x there. You can treat that as a number. Now, if I asked you to integrate, let's say 3 dx, you would know the answer is 3x. And for those who are still confused as to why, because we treat the 3 as if we're saying 3 times x to the power of 0. True? Because x to the power of 0 is 1. 1 times 3 is still 3. These two are technically the same. But the nice thing is if you use this format, you can use the rule. It'll be 3 times x to the power of 0 plus 1 over 0 plus 1, which ends up being 3x. Okay? That's how it works. And don't forget plus c. Alright? So now that I've got 3x to the 5 and these two cancels out, so my final answer is 3/5 x to the power of 5 plus x squared minus 3x plus c. There we go. Easy 2 marks, or 1 mark. Next question. Now, I told you that anytime you get these fractions, you can't derive them individually like you guys did in your SACs. You can't anti-derive them individually. The only thing you can do is simplify it. When it's one term, when it's a whole entire fraction, break it up and simplify. So what I would have done is I would have split this up into 2x squared on x minus 3x on x because they have the same denominator. Why did I do that? Because x divided by x cancels out and x squared divided by x becomes x. So essentially you're really just doing integration from -1 to 2 of 2x minus 3 dx. And that's much easier to do. Now, putting in definite integrals, we're integrating now. Let's integrate 2x. That would be 2x to the power of 1 plus 1, which is 2, over 1 plus 1, which is 2. And then minus, now we knew that integration of 3 ends up being 3x, so minus 3x. And our integration was from -1 to 2. Remember, this type of integral is called definite integrals. There is no need to put the plus c here because it's going to cancel out anyway, if you remember what I explained in class. And so what's the rule here? Remember, we're going to substitute 2 in first and then minus sub -1 in. So I'm going to sub 2 in first. I'm going to have, oh, actually these two cancels out. So you technically have 2 squared minus 3 times the 2 because I substitute 2 in. Okay, so this is substituting 2 in. And then I'm going to minus, now substituting -1 in. So -1 squared minus 3 times -1. See what I'm doing there? That's f of b minus f of a, fundamental theorem of calculus. So here we go. This is 4 minus 6 minus, what's that, 1 plus 3. So that becomes minus 4, and 4 minus 6 is -2. So -2 minus 4 is -6. Okay. Yes. So it means the, well, yeah, it just means the area is, and in this case, you haven't actually learnt much about integration, but this technically means the area is 6 squared units, but it's below the x-axis. Okay, you can have above the x-axis and you can have below the x-axis, the area. But don't worry, that's for next year. Okay, but there you go. It says evaluate and the answer is -6. Let's move on to the next one. Question 4. What does it want me to do? It says find f dash of 1. So f dash is what I need to find first. F dash is the derivative. Most of us can do this one now. Derivative of x cubed is 3x squared minus. Now some students may struggle with the third. Another way of thinking about this is that it's minus 2 times x to the power of, now a square root is the same thing as power of a half. So if you do that now, remember the derivative would be dy dx. Drop down the half, multiplied to the -2 times x to the power of half minus 1. That's the rule, sure? Then half times -2 cancels out to be -1, so you got negative x to the power of -half, which we normally write as -1 on x to the power of half, which is better written as -1 on root x. Okay, I'm just using index laws. -half, we can bring it to the bottom, and that's what I did. And then x to the power of half is the same thing as square root. Okay, so I'm just going to write over here. This is -1 on root x, and then it's plus. Now the 3 on x, similarly, 3 on x is the same drill. We're going to be looking at as 3 on x is the same thing as writing 3 times x negative to the power of negative 1. Now if you find the derivative, drop down the power, so negative 1 times the 3, x to the power of negative 1 minus 1. So you get negative 3 x negative 2. Okay, and another way of writing that is negative 3 times 1 on x squared, which ends up being negative 3 on x squared. Okay, and so here we go, we've got minus, oops, wrong color, minus 3 on x squared. Okay, and now I'm going to substitute now f dash of 1 just means I'm going to substitute 1 to find the gradient. So 3 sub 1 in, minus 1 on root 1, minus 3 on 1 squared, works out to be 3 minus 1 minus 3. And that just ends up being negative 1. Okay. Alright, now, derivatives. Hopefully you watched the 2017 paper. Again, same thing. The first one was a power rule. Now, the second part, this is a product rule. How did I know? Because I can see that there's a sine function multiplied to a log function. So if you have two functions multiplied to each other, it's a product rule. And it's on your formula sheet, but you just need to know which one's your product rule. Yeah? Product rule is VU dash plus UV dash. Yeah, that's Victoria University first. I kept mentioning that. So if I'm going to let U equal to sine of x, then I find the derivative, which we know is cos of x. If I let V equal to log E of x, then the derivative is 1 on x. Okay, then using the rule, then dy dx has to equal to VU dash, so V times the U dash, and you get, what is this, log E of x multiplied to cos of x, plus U times V dash, so U, which is sine of x, multiplied to 1 on x. And that's my answer right there. It's log E of x multiplied to cos of x plus sine of x over x. There you go. Product rule. Okay, so just make sure to know how to use these rules, because I noticed in the SAC that we did for my SAC, not the application SAC, that a lot of students are skipping this step. You understood it was the derivative. Some of you did it just individually. You did like U dash times V dash. No, it's a product rule. Use that rule. Okay. Question 6. Find the coordinates of the point on the curve with the equation y equals x squared minus 4x plus 2 with a tangent. Okay, so tangent is parallel to the straight line with equation. Okay, so it's a parallel problem. What does it mean when they say it's parallel? If it's parallel, it means they have to have the same gradient. Think about it. Two straight lines, if they're parallel, they have to have the same gradient. So essentially, all they're just telling you just now is they just said the gradient of this tangent line is the same as the gradient of this line. And the gradient of this line is 2. So that means this tangent line has a gradient of 2. That's the only way for it to be parallel. Okay, so let's read the question again. Don't get too intimidated when you're looking at these questions. It says, find the coordinates of the point on the curve of this equation where now ignore all this now, because we know it's basically just saying find the point on the curve, so on this curve when the gradient is 2. Now, I kept repeating this. Don't forget the purpose when you're finding derivative. What is the purpose when you're deriving? You are finding the gradient. So if I found the derivative of this is dy dx. That gives you 2x minus 4. This tells me the gradient. This is the gradient. But what do you want to know? You wanted to know the coordinates when the gradient is 2. So if the gradient's 2, then I can find the x coordinate here. I got 2x minus 4 if I add 4 on both sides. They become 6 equals 2x, and therefore x equals to 3. So that means in my coordinates, 3, when x is 3, I don't know what y is yet. I just know at x equals 3, I will have a gradient of 2. Now your job is just to find y. And how do you find y? Well, there you go. They told you here. I said y is equal to whatever x is. You square it minus 4 times the x and then add 2. Don't substitute it back in here. A lot of students don't know what they're doing. They sub it back into the derivative. And, well, if you sub 3 back into the derivative, you're going to get 2. Because we already know the gradient's going to be 2. So there's no point subbing 3 in. Okay, but here we go. We're going to find y. Y is equal to 3 squared minus 4 times 3 plus 2. And we get 9 minus 12 plus 2. And what is that? 9 plus 2 is 11. 11 minus 12 is negative 1. So that just tells me that the y coordinate is negative 1. So what are the coordinates? The coordinates is when it's 3, y is negative 1. There you go. That's the corner of the point when the tangent is parallel to the equation y equals 2x minus 5, because they have the same gradient. That's essentially what it's saying. Okay. Let's move on to the next question, 7. We're almost done, actually. Oh, yeah, there we go. It's quick and easy. Here we go. Let's go to question 7. Let f of x equal this. Find the derivative. Now, this is a chain rule problem. How do you know? Because you've got a quadratic within a quadic. And usually, you'd have to expand the whole thing to find out the answer. But they've made it difficult by putting 3x squared plus 2x. So what your job is meant to do is let u equal to 3x squared plus 2x. And if you do that, why do you do that? Because the now y is equal to u, because you replace this whole thing here, the letter u, it's u to the power 4. That's nice because dy du we can do. It's 4u cubed. But remember with the chain rule, you find dy du, you also need to find du dx. So where do you find du dx? Right here. You've got the equation. You've got u equals to 3x squared plus 2x. So du dx is the derivative of that. And that's, 2 times 3, 6x plus 2. There you go. Now you got du dx and you also have dy du. Then to answer the question, the derivative f dash of x has to equal to 4u cubed multiplied to 6x plus 2. But remember u was made up, so you have to replace it. So it's 4 times 3x squared plus 2x, all to the power 3, multiplied to 6x plus 2. There you go. Done. Okay, technically you can still factorize this out a bit further, but for the sake of answering the question, I'll probably leave it like that. In year 12, you have to factorize it. Okay. And then the next question says find f dash of 1. So now I've got the derivative. Then I just want to sub 1 into the derivative. So here we go. We've got 4 times 3 times 1 squared plus 2 times 1 all cubed times 6 times 1 plus 2. Okay, you got 4, 3 plus 2 is 5 cubed times 6 plus 2. That's not cool. These are pretty large numbers right here. Well, if we break it apart, it's 4 times 5 times 5 times 5 times 6 plus 2 is 8. Alright, can I simplify this any way to make it easy? You know what? Maybe I can do this. 4 times 5 is 20. 5 times 8 is 40. And I still have that 5 in between, but I know 20 times 40 is equal to 800, and then 800 multiplied to the 5. So 5 times 8 is 40 with the 2 zeros. So 4,000. There you go. That's quick and easier. So sometimes you don't have to do it the calculator way. I mean, that would have been quite painful to do if you did 4 times 125. I think that's what 5 cubed is. And then times it by 8. Try to break it apart if you can. Might make it easier. Okay. Anyways, are we on our last question? Okay, we are. All right, here we go. What is this? For the equation, find the coordinates and nature of the stationary points. Remember, stationary points means that the derivative, dy dx, equals 0. And what that basically means is, when will you have a gradient of 0? The only times you have a gradient of a tangent line to equal to 0 is at the maximum or minimum. I hope I've repeated this enough from 2017, and I'm doing it again here, and the applications that we did before I went on camp. Yeah, it's the same drill. dy dx is when the gradient's equal to 0. So you can have a local max, local minimum, or you can have a point of inflection. Okay, so that's what they mean by and the nature of the stationary points. You got to prove it. So here we go. We're going to need to find the derivative first. We need dy dx. Then we let it equal to 0. So here we go, dy dx. Let's find the derivative. That's 3x squared plus, bring down the 2. 2 times 3 over 2 becomes 3x minus 6. Okay. So that's my derivative. And what did I want? I want the derivative to equal to 0. So I've got 3x squared plus 3x minus 6. I can already see there's a common factor of 3, so I'd probably factorize 3 out, so x squared plus x minus 2. Divide 3 on both sides, so then I get x squared plus x minus 2. And then see if I can factorize this. Let's see, to get 1, 2 minus 1. 2 minus 1 is 1, and then negative 1. Yeah, that works, and therefore x is equal to 1. And x is equal to negative 2. Okay, x equals negative 2. So that means I've got 2 stationary points. Now, what I don't know is whether these 2 stationary points is a maximum, minimum, or inflection point. So the only way to know is you're going to use your sign diagram. Okay, so remember the sign diagram, you got x, and this is your gradients. You got the point at negative 2. I like it in sort of order. So I would probably do it something like this. Negative 2, pick a number before and after, and then the number 1 before and after to see what kind of coordinates I have. Now we know the gradients for these two was 0 because we just solved for it. We said when the gradient is 0, find x, and I just found x. When x is negative 2, the gradient 0. When x is 1, the gradient 0. Now, in order to know if it's a maximum or minimum, it depends on whether these two are certain gradients, for example. So if it's like positive gradient here, negative gradient there, 0 gradient, this is clearly a local max because you got that kind of shape. True? Okay. So let's see what my gradients are. Now we got to pick a number between just before negative 2, which I think it'll be easy if I just went with negative 3. And between negative 2 and 1, well, that's pretty easy. Choose 0. 0 is the easiest one to work with. And pick a number after 1, which I'll probably pick 2, just to keep it all simple. Okay, I'm going to start off with 0, because 0 is the easiest one. Now the derivative, let's see, we go. We had dy dx is equal to 3x squared plus 3x minus 6. Now if I subbed x equals 0, just to find out what the gradient is, then dy dx is equal to 0 plus 0 minus 6 is minus 6. So this tells me the gradient's negative 6 when x is 0. It's a negative gradient. So negative gradient, so it's going down. Okay. So this could potentially, at negative 2, when x is negative 2, so I'm just highlighting this, when x is negative 2, potentially this could be a maximum. But we need to find out what the value is on this side. So we do the same thing again. X is equal to negative 3. Then if I sub negative 3 into the derivative to find the gradient, so 3 times negative 3 squared plus 3 times negative 3 minus 6. What's this? 9 times 3 is 27 minus 9 minus 6. What is that? Negative 9 minus 6 is negative 15. So 27 take away 15 is 7 plus 5 is 12. Okay. So gradient of 12, so it's a positive gradient. So yes, we were right. It is a local maximum when x is equals to negative 2. I haven't figured out what the y coordinate is, but we'll leave that for later. Okay, we'll leave that for later. And now the last one, we know this is a negative, but then 1 is 0, what is 2? So now I'm going to sub x equals 2. dy dx is then equal to 3 times 2 squared plus 3 times 2 minus 6. What's that? 3 times 4 is 12 plus 6 minus 6 cancels out. So again, it's 12. So this now gives you a positive gradient. So if it's a positive gradient, clearly this is a minimum because it goes down negative, 0, then positive. That's a minimum. So at 1, at x equals 1, it's a local minimum. Now, the question did say find the coordinates. So I found the x coordinates. So I need to find the y values now. So I know when x is negative 2. I don't know what the y value is yet, but this would be a local max. When x is 1, I don't know what the y value is yet, but I know that it is a local minimum. Now I need to find the y value. So we got to sub negative 2 and 1 back into the original equation because it tells you y. Okay, so sub in negative 2, here we go. If I sub negative 2 in, negative 2 cubed is negative 8, plus 3 over 2 times 2 squared minus 6 times negative 2. This is tedious, actually. Negative 2 squared is 4. 4 divided by 2 is 2. 2 times 3 is 6. So negative 8 plus 6 plus 12. 18 minus 8, so it's 10. So y equals 10. Okay. And then the next one, if I sub 1 in, oh, that's a bit easier. You got 1 plus 3 on 2 minus 6. 1 plus 3 over 2 minus 6. Well, this gives you some sort of fraction, doesn't it? Well, 1 plus 3 on 2 is like, what, 2 times 1 is 2 plus 3. So that's 5 on 2 minus 6. And that equals 2. Negative 12 plus 5 is negative 7 on 2. So negative 3.5 is what the other one answer is. So negative 7 on 2. There you go, local minimum. So I can see why that it's the theory is not hard. It was just tedious because of all the numbers multiplying and adding, but that was 4 marks. Okay, for 2016. A lot of steps there. The steps are straightforward. It was more about subbing in the numbers and working them out without a calculator. It's just the pain. And I'm pretty sure I wrote this exam too, so that's pretty stupid of me. But anyways, I think this is meant to be a comma. Alright, here we go. Now it says find the absolute maximum for the function. So let's put everything back into perspective. We have this equation. We don't know what it looks like. Okay, we don't know what this equation looks like, but we know that it has 2 stationary points. So already it's a positive cubic graph. See, it's x cubed, and it's a positive x cubed. So I already know the shape has to look like this. I knew that it was a local maximum at negative 2, 10, and it's a local minimum at 1, negative 7 on 2. So in terms of the x-axis, it will look something like, maybe like that. I just don't know the x-intercepts at the moment. Okay, but you don't need to know because the question says find the absolute maximum. So I just need to know whether the endpoint is higher than the maximum value, which is 10, or not. Okay, so to test it, there's really no point testing negative 2 because we already tried negative 2. Negative 2, this negative 2 here is actually right there. So it's from, the graph is drawn from negative 2 to 3. So it's likely to start here. And the question is, at 3, is it above or is it below the maximum, the local max? So the only way to test that is if I try out at x equals 3, let's see what the y value is. So f of 3 equals x cubed plus 3 over 2. 3 squared minus 6 times 3. Whoops, there should have been 3 here. 3 cubed. Oh, another painful. 3 times 3 is 9. 27 plus 27 on 2 minus 18. That's not cool. Alright, 27 take away 18 is easier to do. 27 take away 18. That's 7, 8, 9, 9. Plus 27 on 2. And 9 plus 27, 2. 2 times 9 is 18. 18 plus 27. What's that? 45 on 2? Half of 45 is 22.5, which is clearly larger than the 10. So at 3, you've got 22.5. So 3, 22.5. So clearly x equals 3 has to be the highest value because the minimum was at negative 7 on 2 for this one, and we stopped at the domain at negative 2, which is up to 10. So therefore, absolute max has to occur the absolute maximum is at x equals 3, which gives you the absolute max value of, therefore absolute max is equal to 22.5. There you go. Whew, that was, like, the exam wasn't hard. I kind of regret myself writing this exam just because it's tedious to do. It's not hard to do, it's just tedious. A lot of fractions. But anyways, that's exam 1. I'm going to end the video so I can start on the multiple choice questions. Hopefully it should be quick and easy because it's CAS, and then we'll work on extended response questions. Okay, here we go.